Hello friends, today we will discuss solution of the questions which were asked in afternoon session of GATE 2024 related to transportation engineering. The first question is on runway length. The longitudinal section of a runway have gradient as shown in the table. This is given in the question. 0 to 200 plus 1% gradient, 200 to 600 minus 1, 600 to 1200 plus 0.8, 1200 to 1600 plus 0.2%, and in the remaining minus 0.5%. So effective gradient is by definition RL of the highest point on the runway minus RL of the lowest point divided by total length of the runway. Total length of runway is now 2000 meter. So if you assume that the RL of the first point at zero chain is 100, so we can redraw this table here that the length and RL 0, 200 and 2000. So if you assume RL of 0 point as 100, 0 to 100 plus 1% gradient, so in 200 meter there will be 2 meter rise, so RL will be 102. In next 400 meter gradient is minus 1, so there will be minus 4 meter fall, this will be 98 meter. 0.8 for next 600 meter, it will be 102.8 meter. Next 400 meter plus 0.2, so you add another 0.8 meter, so it will be 103.6 meter, and next 400 meter is minus 0.5, so 0.5 into 400, 2 meter, so it will be 101.6 meter. These are RL of different points on the runway. So the lowest point is 98 and highest point is 103.6, and therefore the effective gradient will be RL of highest point 103.6 minus RL of lowest point divided by total length of the runway and multiplied by 100. So this will be 0.28%. That is the answer. The second question is on recall basis. In general, the outer edge is raised above the inner edge in a horizontal curve 4. Now here 4 options are given for highways, railways and taxiways, for highways and railways only, for railways and taxiways only, and highways only. Now here you should understand that taxiway is provided parallel to the main runway. Now this is the runway, and then either at the end of the runway you provide exit in case of short runway, or even in between also we can provide the exit like this. But taxiway is this one. Taxiway is the track parallel to main runway. These are exits, exit taxiway. Exit taxiways are provided with curves, horizontal curves, but taxiway is not provided with horizontal curve, and therefore this super elevation, which is basically raising of outer edge with respect to inner edge, is only in case of highways and in case of railways. So here the option B is correct, highways and railways only. The third question is on stresses in a concrete pavement. And it says various stresses in a jointed plain concrete pavement with slab size of 3.5 meter into 4.5 meter are denoted as below. So stresses can be because of wheel load, or it can be because of temperature or friction. So let us say SIWL is the stress because of wheel load at interior, at edge because of wheel load, and at corner because of wheel load. So this is interior because of wheel load, this is edge, and this is corner. And similarly, for temperature stresses, warping stress at interior. So SI, interior, temperature stress at interior, at edge, and at corner. And one more, that is frictional stress because of friction. So question is the critical stress combination in the concrete slab during a summer midnight will be, and there are 4 options. Now here we should understand how these stresses are developed at different locations of the slab. I have uploaded 2 videos on this aspect. In one video I have discussed only the wheel load stresses. In the second video I have discussed the temperature stresses, friction stresses and their combinations. But briefly I will tell you that when a slab is loaded at the interior location, then this bending occurs like this. In the slab, it will bend like this. And because of this, tensile force will be developed at the bottom and compressive force at the top surface of the slab. Similarly, when the load is applied at edge, the same situation. It will bend like this and tension will be at the bottom and compression at the top. But when it is applied at the corner here, then the tensile stress is developed at the top surface at some distance from the corner. So it will be tensile at top surface and compression at the bottom surface. So if I prepare a, let us say, table here, that because of load, how the stresses are developed because of load. So here it will be at top you have compression, tension, compression, tension, tension, compression. This is because of load. Stresses can be because of temperature also, and temperature can be because of daily variation or it can be seasonal variation. When we take temperature, daily variation temperature, now this is the slab where during summer midday, the top surface is hot and the bottom surface is cool, and therefore this will be curling like this. If it is free to expand, then there will be compression here, tension here. But there is always a support between the slab and the base course, and therefore it doesn't expand or move freely, and because of this reason there is a compressive force at the top and tensile force at the bottom. At the corner, same situation happens at corner also. So you have here C and T. So because of temperature midday, there will be compression at top, tension at bottom, compression at top, tension and compression. During night time, situation is just reverse. Now this is cooler and this is relatively hot. So it will basically curl upward. The slab will curl upward. And again here at the bottom, because of resistance provided by the support system base course, it will have a compression here and it will have a tension here. Now here the corner will now leave the base. They will hang, and because of their own weight, there will be tension here and compression at the bottom. So it is just reverse of what you observed during daytime. So during night, tension, compression, tension, compression, tension, compression. Now frictional force is because of seasonal variation, and in summer the temperature of the entire slab rises. There is no gradient. Entire slab rises, and therefore there will be expansion in both directions. And again this expansion is resisted by the friction force between the base and the slab, and therefore there will be compression in the entire slab. So during summer, there will be compression. Compression, 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 compression. Corners are not affected by this because they are moving. So there is no force, stress generated at the corner. During winter, it will be just reverse. So you can say here, during winter, it will be tension, 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 tension. Now, this matrix can tell you what is the critical combination. Because concrete is weak in tension. So these are the critical combinations. These are the critical combinations. This one. So during summer, there is no tension here at the corner, only compression. This is not critical. And summer midnight, this is the tension here. This is the tension here. And corresponding to that, load stress is also tension in tension here. So this must be the critical combination. Critical combination for summer midnight. That is the V load at the corner, V load at the corner plus temperature stresses at the corner. That is your critical combination. SWLC plus STC. And that is the answer A. Question number 4. A vertical summit curve on a freight corridor is formed at the intersection of two gradients plus 3% and minus 5%. Assume the following. Now these are the data given. Only large size trucks are allowed, where design speed 80 km per hour. I, height of the truck driver above road surface 2.3 meter. Height of the object above road surface for which truck needs to stop 0.35 meter. Total reaction time 2 seconds. Coefficient of friction 0.36. And question is design length of summit curve. What would be the design length of the summit curve? Now here, first you calculate what is stopping side distance. And stopping side distance is given by this equation, 0.278 into V into T plus V square upon 254F. It's a summit curve formed by a positive gradient of 3% followed by a falling gradient of 5%, and therefore this N is 3 minus 5, that is 8% or 0.08. V 80 km per hour, T reaction time that is 2 seconds, friction F value is 0.36, and if you put all these values here, you get SHT is equal to 114.47 meter. This is the stopping side distance. Now, when you determine the length of summit curve, there are two options. One is length of curve may be larger than this or it can be smaller than this. And there are two different equations given in IRC code. So let us assume that L is more than SHD. And the length of the curve is given by this equation, ns square upon 4.4. Now here you should know from where this 4.4 is coming. N is 0.08, S is stopping side distance. Now original equation is ns square upon square root of 2h plus square root of 2 small h whole square. That is the original equation. Now, if you put value of h in a normal case, which you take a driver of the car, h capital H is taken 1.2, small h is taken 0.15, and this becomes 4.4. Now, in this question, h is given, capital H is given 2.3 meter, small h 0.35 meter, and therefore this will be Now L will be N 0.08 multiplied by 114 into 47 square divided by square root of 2 into 2.3 plus square root of 2 into 0.35 and whole square. This is 117.93 meter. And because this value is now more than SSD, so our assumption that L is more than SSD is correct. And you have to put the answer rounded off to 2 place of decimals, and therefore this is the answer, 117.93 meter. That is question number 4. Question number 5. A horizontal curve of radius 1080 meter with transition on either side in a broad gauge railway track is designed and constructed for an equilibrium speed of 70 km per hour. After a few years of construction, Railway Authority decided to run express trains on this track. What would be the maximum allowable speed or maximum restricted speed of the express train running on this track if the allowable cant deficiency is 10 centimeter? So this is in 2 parts. First, you find out what was the cant provided in the initial time of construction of this railway track for a design speed or equilibrium speed of 70 km per hour. If V is 70 km per hour, then equilibrium cant is GV square upon 127 R. And because this is a broad gauge, so G is 1750 millimeter, that is dynamic gauge. V is 70 km per hour and R is 1080 meter. Now if you put these values in this equation, you get E equilibrium is 62.52 millimeter. This was the cant originally provided on the track. Now if you permit cant deficiency on this, cant deficiency is CD. CD is 10 centimeter, means 100 millimeter. So E plus CD, it will be 162.52 millimeter. Put this value here, find out what is the new speed. That would be the speed restricted for express trains. So 162.52 is G, 1750. V, now you have to find out 127 into 1080. And if you solve this equation, this is 112.86 kilometer per hour. Taking advantage of full cant deficiency, answer is to be written rounded off to the nearest integer. Now this must be rounded off to the lower digit, because if you round it off to higher digit, 113 km per hour, then this E plus CD will be insufficient. And therefore, the correct answer should be 112 km per hour. That is the restricted speed for express trains. That is question number 5. Question number 6 is theoretical question. In the context of pavement material characterization, the correct statement or statements are: number 1, the load penetration curve of CBR test may need original correction due to non-vertical penetration plunger of the loading machine. Now this is a true statement in the sense, because when you draw load penetration curve, ideally it should be like this. This is the penetration and this is the load. But because of some error in the experiment, it might be because the top surface of the soil is soft, not compacted, or it may be the plunger is not vertically placed. Then this curve takes a concave shape in the beginning and then it becomes like that. Now this is what we call the zero correction. So zero correction is required sometimes. So A is correct. The toughness and hardness of road aggregates are determined by Los Angeles aversion test and aggregate impact test respectively. Now this is reverse actually. Toughness is measured using impact test and hardness is measured using abrasion test. So this statement is not correct. Third, grading of normal bitumen binder is done based on viscosity test results. Yes, because now IS 73 classify bitumen based on viscosity and therefore viscosity grades are being followed in India. So statement C is also correct. D, in compacted bituminous mix, wires in mineral aggregate is equal to sum of total volume of air wires and total volume of bitumen. VMA is equal to VB plus VP. You can watch my video on VMA. This is a correct statement. VMA is composed of total air wires plus total volume of bitumen in the mix. So statements A, C and D are correct. Only B is not correct. Question number 7 is a bit longer question. The consolidated data of a spot speed study for a certain stretch of a highway is given in the following table, and a table is given. This is the data given. The speed range from 0 to 100 in steps of 10 km per hour and frequency, number of observations. Question is the upper speed limit for the traffic sign. Now, upper speed limit for traffic sign is 85th percentile. 85th percentile speed means 85% of the drivers will be traveling at or below that particular speed. So, using this data, we have to find the 85th percentile speed. So, you add one more column here and let us say cumulative number or cumulative frequency. Cumulative frequency. So first row is 7, next 7 plus 31, that is 38, 38 plus 76, 114, 114 plus 129, that is 243, and so on. You complete this column. So this is the now cumulative frequency, 500, final figure is 500. If you take sum of all these values, it will be 500. Next column, you find out what is the percent cumulative or cumulative in percent. So this will be cumulative in percent. So this is 7 by 500 multiplied by 100. This is 1.4. 1.4. 7 by 500. Similarly here, 38 by 500 multiplied by 100. And this value will be 7.6%. 7.6%. Similarly, you calculate for each row. So we have calculated now cumulative percentage in this column. Now you look at 85 percentile. Now incidentally here you get 85, exactly 85% at this speed. If you do not get it, then interpolate it corresponding to 85%. And speed range is 50 to 60 and therefore the upper speed limit for the traffic sign will be 85th percentile. 85th percentile is 50 to 60. So we should take average of these two, 50 plus 60 by 2, that is 55 km per hour. That is the answer. Answers are 50, 55, 70, 65. And correct answer is B, that is 55. So these were 7 questions in the afternoon session of GATE 2024. Thank you very much for watching this video. If you have any question, you can write in the comment box.